Hello folks, welcome to our next project. This is an example of probably my favorite kind of clock. This is a jeweler's regulator. This one happens to be a Gilbert regulator number 7. It stands over 8 feet tall, and I picked it up to see what we can do to return it to some of its former glory. Let's get going. As with most jeweler's regulators, this has a 12-inch porcelain dial. It has a gridiron pendulum, and there is a weight in the back behind the pendulum. These can be either pinwheel or deadbeat, and these were not made by Gilbert. These were made either in France or in Switzerland, and then Gilbert in this case was the case manufacturer. This one ticks if I advance the pendulum manually, but what happens is very quickly if I let this go, it starts wobbling and the clock will stop itself. So I wonder if we have a problem with the suspension spring. So that's going to be our first order of business. We'll take the movement out, see what may be broken inside, and then we'll get this running. So here is the inside of our movement. We can see that this is a pinwheel escapement. There is our pinwheel. The pins stick up, and then the pallet on the pinwheel is very different than a deadbeat. We have our pendulum leader here. Here is the suspension spring, which I'm suspicious may be the problem here. We have our main weight winding drum. This inner gear hides our maintaining power, which is like battery backup for the clock, so it will keep running forward even when you're winding it. And then we have all of the gears here. One of the things that I really like about precision clocks like this is the workmanship. These were not built to a price like a typical kitchen clock would be that would be just stamped. Everything in here is machined. Everything is very precise, very well made, and that makes them really delightful to work on. So to get inside of this guy, we need to take the hands off, and we will dismount our dial from the outside of the box, and then we can see inside. This is something that's very common to see. When the clock isn't running, just add a whole bunch more oil. Now these clocks, this is actually the pivot of the escape wheel. So there is a little bushing that threads in, which on the inside of that is the bearing surface for that end of the escape wheel, but just smearing everything in oil does not make a broken clock run better. So it's just always funny to see the lake of oil. Here we are inside the movement. Taking a quick look at the suspension spring, I do not see any obvious tear in there, so we may have something that's just out of balance on the pendulum. We'll take a look at that a little bit later. We needed to get into the movement anyway. So working on this, we need to take off the main pendulum leader here, and then we will actually probably have to remove the back of the movement to get to the gear train there. I removed the iron cover off the back of the movement, and we can see the back plate of the movement itself here. And I want to draw your attention to these pivots. These are very, very small, and as is very typical of these clocks, they're in quite good shape. I may have bushed one of these at one point, but I've done a number of these clocks, and they are so nicely made that there's rarely any bushing work to be done here. Once again, we have our lake of oil. So getting farther in, we'll take this back movement plate off, then we can get to our gear train. We'll get this polished and cleaned, and then we'll see what we have. Here is the gear train, and these are all machined gears rather than stamped, with a little bit of maintaining power left there. These are just beautiful, beautiful parts. And then here is our pinwheel, and this is interesting in that the pins don't actually go through the plate. They are just staked in, I think. And this is not especially thick. So we'll get this cleaned up. I'm hoping that the imperfections on these pins are just gunk and not wear, but the ultrasonic process will help us see that more clearly. And you can see on this how long the shaft of the escape wheel is. This bushing goes all the way out through the dial, and then between the hands, and the second hand attaches directly to this on the outside of the pivot. And then here is our pinwheel escapement itself. You can see these two pallets look very, very different than a deadbeat escapement. We have our winding pawl here. and then our cable drum, and that's about it. There's very few parts to a clock like this. They're just all very nicely made. Another point of interest, this is inside the maintaining power mechanism that's on the winding barrel here. This is the maintaining power spring. It goes through a hole in this plate here, and then this pin sticks up into the barrel itself. And the maintaining power is by deforming this spring just, the equivalent of maybe 5 degrees around the winding drum. But that's enough to keep the clock running forward. And then here is one of the click springs that's inside the drum. I've got the movement polished, cleaned, and reassembled, and it's running freely. It seems like things are okay. Mentioned these pinwheel pins, and unfortunately that is some wear there. I think it's quite a project to try to replace those, so we're going to see if it'll run in the way that it is. Thought about potentially moving the pallets back on the shaft, but due to the end shake of everything going on here, there really isn't any room to move that. So if this isn't good enough, it'll have to be repinned, but don't want to cross that bridge until we get there. So we're going to put this back in the clock and see if we can get it to run in balance. So I think this might be what's going on with our balance problem. This is the top of the pendulum, and if you compare it to the black line behind it as a reference, it's going downhill. So I wonder if this pendulum was just kind of bent in transit somewhere. So I'm going to try to straighten that out, and I think that might solve our problem. With the pendulum straightened, it does indeed run. It doesn't do that extreme wobble that it did when we first got the clock in. There is one issue that is of concern here, and that is if I tighten this front bushing all the way, the clock loses power and binds. So there's something that needs a little adjustment on the minute pinion there. But other than that, this thing is going to work. Well, solved our issue here. There was a little bit of debris underneath here somewhere that was preventing this minute wheel from sitting down all the way, and now we can see that our internal shaft there, that is the fixed part, is proud of the moving minute wheel. So when we put our minute arbor on, this now is going to run easily because there's now slop. Before there was no slop in here. So that should be the end of our mechanical work. Now we're going to start attending to the case.